Welcome to section 5.2, Sum and Difference Formulas. As we continue to explore trigonometric identities, you'll find that not all angles we work with are common angles from the unit circle, like 30 degrees, 45 degrees, 60 degrees, 180 degrees, and so on. Sometimes we're asked to find the exact value of a trigonometric function for less familiar angles, like 75 degrees, 115 degrees, 105 degrees, or other sums and differences of known angles. This is where the sum and difference formulas become powerful tools. These formulas allow us to break down complex angles into sums or differences of angles we already know from the unit circle. This helps us to find exact values without relying on a calculator. In this section, we have one objective. Find the value of trigonometric functions using sum and difference formulas. Here are the formulas you'll use. For sine, we have the sine of A plus or minus B equals the sine of A times cosine B plus or minus cosine A times sine B. So we use this plus sign for the angle sums and the subtraction sign for angle differences. So if it's plus two angles, then in the formula we will use the plus sign. If it's minus two angles, then we will use the minus sign in the formula. For cosine, it's a little different. So we have cosine A plus or minus B equals cosine A times cosine B minus plus sine A times sine B. So here the signs are the opposites. So for the sum of angles, we'll use the subtraction symbol in the formula. And for the difference of angles, we will use the addition symbol in the formula. For tangent, we have tan of A plus or minus B equals tan A plus or minus tan B divided by 1 minus plus tan A times tan B. Okay, so the signs in the numerator are going to match the operation, while the signs in the denominator are the opposite. So if we're adding two angles, the numerator will be positive, or the plus sign, and the denominator will be the subtraction symbol. If we are subtracting two angles, the numerator will also be subtraction, and the denominator will be addition. Now this tangent formula is derived from the formula tan A plus or minus B equals sine A plus or minus B divided by the cosine A plus or minus B. So if we take the formulas for sine plus or minus, or A plus or minus B divided by cosine A plus or minus B, and we simplified it all the way down, we would get the formula for tan A plus or minus B. So sometimes when you are solving problems involving the sum and difference formulas for tan, you might utilize either formula. All right. So to find the exact value of a trigonometric function involving an angle that is not on the unit circle, you can rewrite the angle as the sum or difference of two special angles, like 30 degrees, 45 degrees, 60 degrees, or their radian equivalents. So here are 4 steps to help us in solving problems that utilize the sum and difference formulas. Step number 1 tells us to express the given angle as the sum or difference of two angles with known values. For example, If I am told that the angle measure I'm trying to find a measurement of is 75 degrees, well, I can rewrite 75 as the sum of two angle measurements that I can identify easily on the unit circle. And that would be 45 and 30. Okay, so 45 degrees plus 30 degrees. I can also do their radian equivalent. So 5 pi over 12 will equal pi over 3 plus pi over 4, which are two radian measurements that I can find on the unit circle. Step 2 is to choose the correct formula. So whether that be sine, cosine, or tangent, depending on what your question is asking you to find. Step 3, substitute the known values from the unit circle for sine A, cosine A, sine B, cosine B, tangent, whatever the trig function you are looking for. And then step 4, simplify to find the exact value. So we always want to make sure that our answer is in the most simplified form before concluding with the problem. So let's do some problems together. In our first problem here, we're asked to find the exact value of cosine of 15 degrees. Now, cosine of 15 degrees is not or does not contain an angle measure that is a part of the unit circle. So I need to rewrite this where its sum or difference is going to be equal to 15 degrees. So two angle measures that I'm going to use are going to be 45 degrees and 30 degrees. Okay, when I subtract these two values, I get 15 degrees. So I can use the cosine formula where I am subtracting two angle measurements in order to find the exact value of cosine 15 degrees. So I'm going to take cosine, plugging this in. 45 will be my A, 30 will be my B angle. So I have cosine of 45 times the cosine of 30 plus, because cosine's the opposite, the sine of 45 times the sine of 30. So the cosine of 45 degrees is the square root 2 over 2. The cosine of 30 degrees is the square root 3 over 2, and I'm multiplying both of those values, plus the sine of 45 is the square root 2 over 2, and the sine of 30 degrees is 1/2. Okay. Multiplying fractions, I multiply across, so I'll have the square root 6 over 4 plus the square root 2 over 4. Since they have the same denominator, I can combine the numerators and place everything under the same denominator, which is 4. So the cosine of 15 degrees is going to be equal to square root 6 plus square root 2 all over 4. All right. Next, we're asked to show that the sine of x plus pi over 2 equals cosine x. All right, so this is going to be similar to the identities that we've worked with in previous sections. And we know when it comes to proving identities, we want to start with the side that is the most complicated. And that, in this problem, is the left-hand side. So, the sine of x plus pi over 2, I know that pi over 2 is equivalent to 90 degrees. So just for me to visually see it, because writing it in degrees may be easier for you to see. If you would prefer to write it in radians, by all means, you definitely can. But you can also rewrite this in degrees just to help you see it a little better. So the sine of x plus 90 degrees. So we are taking the sum of two angles, so we are going to use this formula right here at the top. Since it's sine, it's going to be the same operation. So x is going to be a, and 90 degrees, or pi over 2, will be b. So we have the sine of x times the sine of 90 degrees plus the cosine of x times the, I wrote it incorrectly. My apologies. Let's rewrite that. I'm still looking at something else. So we have the sine of x times the cosine of 90 degrees plus cosine x times the sine of 90 degrees. There we go. So that is a simple mistake we can easily make. Just make sure that you verify that the formula that you write down matches exactly what is written here in our formula chart. All right, let's simplify this. So we don't know the sine of x, so we'll bring that down. The cosine of 90 degrees is 0. We don't know cosine x, and the sine of 90 degrees is 1. Well, anything times 0 is 0, so we know this is canceled. And cosine x times 1 gives us cosine x. Okay? And so we just showed that the sine of x plus pi over 2 equals cosine x. All right. Now we're asked to write the sine of 5x times cosine x plus cosine 5x times sine x as a single sine. So we know that we're working with the sine formulas. We just now need to identify which sine formula we'll be working with. So we have the sine of 5x times cosine x plus cosine 5x times sine x. So our operation here is addition. So that means we'll be working with the sine of a plus b. So in identifying what a is, I am just going to write the formula under here, the sine of a cosine b plus cosine a sine b. And I see here that a is 5x and b is x. So in writing this as a single sine, I'll have the sine of 5x plus x as my single sine that represents this formula, which we can simplify to the sine of 6x. Okay. Now, in this problem, we're asked to show that the sine of 90 degrees minus x equals cosine x. So this is similar to the last problem, or one of the last problems we did, where we had x plus pi over 2, or x plus 90 degrees. Now we're taking 90 degrees minus x. So we want to see if this left side is equivalent to cosine x. Now the left side is the more complicated part, so that's what we're going to work with. So the sine of 90 degrees minus x. So we're subtracting two angles. So we'll use the sine with the difference of two angles formula. So that will be the sine of A, which is 90, cosine B, which is x, minus cosine A, which is 90, times sine B, which is x. Now the sine of 90 degrees is 1, and then we have cosine x, minus the cosine of 90 degrees, which is 0, and we have sine x. Now anything times 0 is 0, so this term is canceled, leaving us with 1 times cosine, which is just cosine x. And so we have now proved that that sine of 90 minus x is equal to cosine x. Now let's go back to finding exact values, but in this case we are working with an angle measure in radians. So we are going to find the exact value of 5 pi over 12. Now, as I previously mentioned, by all means you can continue working in radians, but most times it's easier to work in degrees if you are able to convert your radian measure to degrees. And I believe we can do that. So let's convert 5 pi over 12 to degrees. To do that, we'll multiply it by the ratio 180 over pi. Here the pi's cancel. That leaves us with 900 over 12, which simplifies to 75 degrees. So we know 5 pi over 12 is equivalent to 75 degrees. So I can rewrite this as cosine of 75 degrees. So now I want to rewrite 75 as either the sum or difference of two angle measures. I'm going to do the sum because I know 45 plus 30 is equal to 75. So I'll use the sum of two angle measures to help me find the cosine of 75. So using that formula, I'll have the cosine of A, which is 45, times the cosine of B, which is 30. Since I'm dealing with cosine, my operation in the middle is the opposite. Then I have the sine of A, which is 45, times the sine of B, which is 30. Okay? Now the cosine of 45 degrees is the square root 2 over 2. The cosine of 30 degrees is the square root 3 over 2. The sine of 45 degrees is square root 2 over 2. And the sine of 30 degrees is 1/2. Or sorry, 1/2. But I wrote 1/3. So let me rewrite that. 1/2. There we go. Simplifying this, we'll have the square root 6 over 4 minus the square root 2 over 4. Combining this, we have the square root 6 minus square root 2 all over 4. Awesome. All right, our next problem here tells us that if cosine A equals -7 over 25 with A in quadrant 3, and sine B equals 4 over 5 with B in quadrant 1, find the sine of A minus B, the cosine of A minus B, and the tangent of A minus B. So that means we are going to be using this formula, and this formula. Okay? So in our problem, we know we're dealing with two angles A and B. We know the cosine of A is -7 over 25 with A in quadrant 3. So using our memory here, all students take calculus. In quadrant 3, only tangent is positive, which is why cosine is negative. Then sine of B, sine of B equals 4 over 5. And B is in quadrant 1. Okay, so quadrant 1, all trig functions are positive. All right, so now that we know cosine A and sine B, we're going to need to find sine A and cosine B. All right, so first we'll find sine A. So since A is in quadrant 3, all right, the sine A is going to be equal to negative square root 1 minus cosine squared A. Remember, that's derived from the Pythagorean identity, where we have sine squared plus cosine squared equals 1. Okay. Now, when we take the square root, it's obviously positive or negative, but since we're in quadrant 3, we know only tangent is positive, so the sign of A here will be negative. So we have negative square root 1 minus cosine squared A. We know cosine A is negative 7 over 25. So we'll square that value. So we'll have, when we simplify this, negative 24 over 25. So that's the sine of A. Okay. Now, since B is in quadrant 1, we know that the cosine of B will be positive. So that will be the positive square root of 1 minus sine squared B. Okay. So we'll have the square root of 1 minus 4 over 5, which is equal to sine B, and we'll square that value. When we simplify this expression under the square root, we will get, let's give you a more simplified answer, 3 over 5. Okay, so now we have the sine A, cosine A, sine B, and cosine B. Okay, and so now we can utilize those values to find sine A minus B, cosine A minus B, and tan A minus B. All right. Okay, so I moved to another screen just to give us some more space. So we know cosine A is negative 7 over 25. Sine A is negative 24 over 25. Sine B is 4 over 5. And cosine B is 3 over 5. So let's first find the sine of A minus B. So our formula for this is the sine of A times cosine B minus cosine A sine B. So the sine of A we know is negative 24 over 25. Cosine B is 3 over 5. Cosine A is negative 7 over 25. Sine B is 4 over 5. Simplifying each term, we would get negative 72 over 125 minus negative 28 over 125. So when you subtract a negative, it becomes positive. So we're actually adding 28 over 125 to negative 72 over 125, which gets us 144 over 125. All right. Now let's find the cosine of A minus B. Our formula is cosine A times cosine B minus, oh, actually plus, because it's the opposite. So we're subtracting 2, so it's actually positive. So plus sine A sine B. Substituting in our values, we have negative 7 over 25 times 3 over 5 plus negative 24 over 25 times 4 over 5. So we'll have negative 21 over 125 plus a negative 96 over 125. So when you are adding a negative number, you are subtracting. So we'll subtract 96 over 125 from negative 21 over 125, which gives us 117 over 125. So it's a negative value. Okay. All right. And so now we can find the tan of A minus B. So since we know the sine and we know the cosine, we can use the formula sine of A minus B divided by cosine of A minus B. Okay? So we'll take the sine of A minus B, which is negative 144 over 125, and we'll divide it by negative 117 over 125, which is cosine of A minus B. We can rewrite this horizontally. Then apply, keep, change, flip in order to change this to a multiplication problem. You see here that the 125s cancel. The negatives become positive, leaving us with 44. I don't know why I put 144. Sorry about that. 44 over 117. And that is the tan of A minus B. Whew. All right. So now we're going to do a similar one. This time, if the sine of A equals negative 8 over 17 with A in quadrant 3, and cosine B equals 7 over 25 with B in quadrant 1, find the tan of A minus B using the formula. The tan of A minus B equals tan of A minus tan B divided by 1 plus tan A times tan B. Okay, so in the last problem, we did the sine over cosine for tan. This time, they want us to use the derived formula of tan A minus B equals tan A minus tan B over 1 plus tan A times tan B. Well, in order to even utilize that formula, I know that I'm going to have to find the cosine and sine of both angles. That's the only way I'll be able to identify the tan of A and the tan of B. So, similar to the last problem, we are given two very important pieces of information. Okay, so we know that the sine of A is negative 8 over 17 with A in quadrant 3. So if we wanted to find the cosine of A, since A is in quadrant 3, the cosine of A is going to be negative. Remember our acronym, all students take calculus in quadrant 3. The tangent is positive, which means cosine and sine are negative. So we have negative square root 1 minus sine squared a. So plugging in sine a, which is negative a over 17, simplifying that expression. In our calculator, we get negative 15 over 17. So that's the cosine of a. All right. Now, for b, we get that from the second most important piece of information in this problem, where it says cosine b equals 7 over 25 with b in quadrant 1. Since b is in quadrant 1, we know that all trig functions are going to be positive. So in trying to find the sine of b, we know our square root is going to be positive. Okay? So the cosine of b is 7 over 25, which we will square. When we simplify this expression, we get 24 over 25. So now we know the sine of a, the cosine b, the cosine a, and the sine b. All right? Okay, so let me just quickly rewrite that key information up here at the top before we continue on. So sine A is negative 8 over 17. Cosine A is negative 15 over 17. Sine B is 24 over 25. And cosine B is 7 over 25. So now that we have this information, we can find the tan of A, which is the sine of A over the cosine of A, which would be negative 8 over 17 divided by negative 15 over 17, which will equal 8 over 15. Then the tan of B will be the sine of B over the cosine of B, which will equal 24 over 25 divided by 7 over 25, which equals 24 over 7. So now we can utilize the trig sum and difference formula for tan, more specifically the difference formula for tan, which equals the tan of A minus the tan of B divided by 1 plus the tan of A times the tan of B. Well, we know the tan of A is 8 over 15. We know the tan of B is 24 over 7. Then in the denominator, we have 1 plus the tan of A, which is 8 over 15, times the tan of B, which is 24 over 7. And so now we have to simplify this. So in the numerator, we can get common denominators by multiplying our first fraction by 7 in the numerator and the denominator, and then our second fraction by 15 in the numerator and denominator. Then in the denominator, we are going to multiply across. So in doing so, we will get 56 minus 360 divided by 1 plus 192 over 105. Okay. Oop. Our denominator is also over 105. My apologies. I didn't write the denominator. Let me quickly write that for you. So 56 over 105. Yep. Awesome. Okay. So we can simplify this some more. So in the numerator, we'll have it's minus 360. So that's 304 over 105. And then we're adding 1. So we're adding 105 to the numerator. And that will be 297 over 105. Okay. The numerator and denominator have the same denominator, so we can cancel those out, which gives us 304 divided by 297. And that, my friends, is our final answer. Whew, that was kind of fun. All right, our last one for today. We're asked to graph y equals 5 cosine 6x cosine 4x plus 5 times sine 6x sine 4x for x greater than or equal to 0 and less than equals 2 pi. So that means we're graphing between 0 and 2 pi only. All right, so let's take this equation here and let's simplify the right-hand side. Now both terms are being divided by, or sorry, multiplied by 5. So the first thing that I would do in trying to simplify this expression is to factor out a 5. So I'll get 5 times cosine x cosine 4x plus sine 6x sine 4x. Okay. Now, in looking at this, I see here that my angle is for A is going to be 6x, and my angle for B is going to be 4x, and I am adding. So if I look at my formula list here, I have cosine, cosine, and then sine, sine. So that's going to be similar to one of the cosine sum and difference formulas. Since I am adding, I know that my difference formula is going to be the opposite sign. So that's going to be cosine of my A, which is 6x, minus my B, which is 4x. Okay, so this is the formula that we are using, okay, because it matches, the right side here matches what is given in this problem. I can then simplify this to 5 times the cosine of 2x. So y equals 5 times cosine 2x. So if we were to graph this formula, we know that our amplitude will equal 5 and our period will be 2 pi over pi, sorry, over 2, which equals pi. The brain worked faster in my writing. All right, so we will complete one full rotation in pi. All right. So for cosine graph, our amplitude is 5, so we'll start at 5. Okay. Then when we go to pi over 2, we'll go all the way down to -5. And then when we go to pi, it'll be 5, 3 pi over 2, negative 5, and then pi 5. Then in between, so pi over 4 will be our zeros. Okay. Then we can connect the dots. Ooh, let's do that one again. I didn't like how that one looked. It's not even that much better, but okay, I'm getting the hang of it. Alrighty, there we go. All right, so between 0 and 2 pi. So we've graphed now 5 times cosine 2x. All right, and that concludes section 5.2.